Hello and welcome to the Automation Village production profiles. Today we are going to talk to James Denton and Sam Black from the Electric Machine Company out of Birmingham, Alabama. And we're going to talk about the installation that they created for the city of Valdosta, Georgia. Hi, gentlemen. Tell us about EMC. What do you do and who do you serve?
Electric Machine Control is in Trussville, Alabama, which is a suburb of Birmingham. Our primary market for water and wastewater is the Southeast United States. But industrially, we go all over the world. We serve OEMs, we serve general industry, and then we have a focus on the water and wastewater market.
So how did EMC become involved with the city of Valdosta to begin with?
So our initial contact was through customer referral. Obviously, with any type of project like this, it has to go out for competitive bid. They bid it based on a performance type bid as opposed to a bid that was just strictly on price. So not only were they evaluating us, but they were also evaluating the software that we were presenting and how we might apply the software to their application.
What kind of infrastructure was this bid around managing?
Okay, so this project included a total system upgrade for them, hardware, software, and network infrastructure upgrade. They have 3 plants. They have 2 wastewater treatment plants and a water treatment plant. They have approximately 40 to 45 remote sites. Those encompass lift stations, water booster stations, water production wells.
So you ultimately chose VT SCADA software, which, to be honest, that's our software made by Trihedral Engineering. What made you choose that as a platform?
So with every customer, especially customers that we're unfamiliar with, we'll go in and find out what their needs are. We'll find out a specific goal that they have in mind. They had a goal. They wanted to be more efficient at running their systems so that they could more easily meet requirements of Georgia environmental regulatory agencies. So they asked us to come in. And in that discovery process, we found that they were running multiple software packages for SCADA at their plants. And then at their remote sites, they had also multiple different dissimilar systems that were trying to give them the same information. With that, we looked at the software that would be most appropriate for their application to help them achieve the goal. And VT SCADA lent itself well to that because of the redundancy that you can allow servers to back each other up. The various protocols that you guys offer, because they had anything from flight multi-smart systems out there to Grundfos controllers. They have generators that have Modbus RTU. So there were a number of protocols out there, and same thing applied to the plants. They had a number of protocols there. VT SCADA had all these protocols, already embedded into the software. So we reviewed that. We gave that to them. We told them the features and benefits, and VT SCADA was the package they chose.
So what are the benefits of unifying under a single SCADA platform as opposed to, as you said, having different systems for different parts of the utility?
Yeah, so with a utility of that size, they want to cross-train their personnel. They want to be able to, in the event, they're close to the coastal region of the U.S., so in the event of bad weather, like hurricanes, for example, they can reach as far inland as Valdosta. They wanted to be able to drop back to a central location and still view their entire system. The advantage that VT SCADA brought, using it across the city, from everything from collections to water distribution to plants, even though, wastewater is different than producing water, we could do a common training for them. So, if a guy were to move from one department to the next, he wouldn't have to relearn how to interact with the SCADA system.
So, Sam, in working on this project, what was your approach to getting this done?
One of my favorite things about VT SCADA is the way that it handles growth. So we saw that they had, so many lift stations we had to integrate. Rather than designing a whole bunch of individual pages for each thing, we can build one master page and parameterize that with widgets and parameters, frankly, to build out something that when we need to add a station, all we do is copy paste the tags and link it into a new page. So we can really dive in and make that one screen fantastic.
That's great. So you mentioned screens. Tell me about your process for, like, what design methodology do you use for creating these parameterized reusable pages?
Our kind of core design concept is high performance graphics. So that means a lot of grayscale, a lot of not flashy things that are going to distract you from the action that really needs to grab your eyes. So VT has got a lot of built-in features now where we can put those in without too much effort. It also dictates that you have a layered approach to your screens. So you have an overview screen where you get big picture items, click on a component to blow that up and learn more about it. So let's say you've got an overview of your collection system. You can click on an item in that collection system to learn more about that station. And now you see, oh, I've got a problem with the power. You can click on that and it'll expand out and tell you about specifically what that power problem is. And then one step further even is you can use the built-in trending to click on the problem and see when it happened, how often it's been happening.
That's a great description of how that works. So often you see people sort of say, oh, the screen is gray, it's high performance, ta-da, and move on from there. But there really is a much larger methodology around that.
This is a screen that Sam developed. You know, we read the book that was written for high performance graphics. We saw some examples in there. One of the things they showed is that wasn't related to collection or distribution systems is how they applied high performance graphics to train schedules for subway views. How they figured out, you know, where the train's running on time and getting to where they needed to go. We thought, hey, pushing water down a pipe isn't much different than a train. So let's develop a screen that gives a bird's eye view to a customer. So you can see with this screen right here, this is an adaptation of that subway view.
Yeah, this is so kind of using some of the more modern features in VT. As a smaller collection system, we're able to fit more information on the screen. We noticed that when people were opening these pump station views, the thing that they were most interested in was what have the pumps been doing as far as running history, and what has the well been doing as far as level history. So with the extra real estate afforded by a high resolution screen, we've taken that information and embedded it directly on the subway view. So here at a glance, you can see, you know, are my pumps alternating? Have the levels done anything strange recently? How do my comms look? It still follows the same principle of, you know, white is running. So you can get the same information. We've also broken out the information available on the overview screen a little bit more in depth. So on stations that support it tag-wise, we've actually got little icons that show you where a problem's coming from. So here you can see at this station, it not only has a problem, we can say that the problem is with pump 3. And if you want to learn more about that, you would click into it. So we get our sort of level 2 screen here. We can see in the station, pump 3 does have a fault. If you wanted to learn more about that pump, you can click on it there, or you can click on it here. So this is kind of a way to drill down into every possible piece of information about that station. But again, you can see we've got our trend on level and our trend on pump run status. All that data is available at a glance on the main screen.
And the information that you see between those two boxes, we're scraping that from the USGS, you know, basically NOAA's website, weather.gov. They want to know wind speed. They want to know precipitation. That gauge height is the local river. Discharge is the calculated flow through that river right at the moment. That's important for them to know. So we've scraped that data and brought that in, and they can trend that and compare it. So like the precipitation, they can compare that to what's going through their stations and identify I&I issues. Yeah, so you can see an anomaly right there.
Yeah, so by scraping data through JSON drivers, you can sort of cross-reference that against what your stations are doing. So at the top, you've got your transducer level at that station over the last 4 weeks. Underneath that, you've got the gauge height of the river. And underneath that, you've got the river discharge. So you see that the gauge height and the discharge are pretty closely related, as you'd expect. Beneath that, you've got the number of pump starts for that station. You know, without these middle two graphs, you might just look at this trend and say, oh, what happened on June 7th? Is there a problem with the station? But by comparing it against data from the river, you can say, oh, there must have been a rain event. This is normal operation and nothing to worry about. Another thing we've been playing with is this radar chart. So we use some scripting to run a calculation on what sorts of problems your system is having, whether that's a communication problem, a panel problem, pumps, wet wells. And it uses that to form a KPI for, you know, how is your system doing at this moment? So these lines here will pull in and out depending on what areas of your system need improving.
So the idea being that an operator from across the room could look at that shape, and if it looks nice and regular and even, then they know everything's probably pretty good. But if that shape suddenly twists itself into something different, they know they've got to come over and take a closer look.
Absolutely. So we always have, when we go out and we talk to utilities, they're like, hey, we need to know when we have problems. For example, a high level. Hey, I want to know when I have a high level at my lift station. Well, we always say, well, that's too late. Don't you want to know before you have a high level? And that's the whole purpose behind this design. You know, we always have people say we want accuracy. Well, we always say, well, you know, accuracy is important. You can calibrate for accuracy as long as things are repeatable. So what we want to show them is that, hey, the system's healthy and everything is repeating like it should. When you see a deviation from a repetitive performance, then you have to start paying attention to it. And if you start seeing those deviations, and the way Sam's got this laid out here, you can start determining things when they're deviating from normal. You can get ahead of the high level.
So did you actually, during the course of the project, make any changes to the PLC network or the radio network at all?
Yes. So we found several stations that run old radio systems. So in all of those stations, we've went in and installed a cellular modem on Verizon's network. So we go in and put that on Ethernet and then tie it into the new SCADA. Their old system, actually, a lot of it, there was no viewing. They had a alarm agent that would look for an alarm and make a phone call, and hopefully that call goes out. Hopefully someone's been paying attention.
Right.
There's a lot of things that can go wrong there. So by moving them to cellular, we can have some resiliency and some peace of mind. They can tune in and see, okay, everything is fine.
So then you're using the integrated VT SCADA alarm notification system, is that right?
Yes, absolutely. Remote access as well.
Tell me about that.
So we are currently in the process of getting their TLS certificate set up so that they can remote in from home. But right now, if you're at any of their facilities, any of the supervisors or operators have a link they can go to and sign on to view their collection system or treatment facilities.
Tell me about the architecture of the completed system in terms of servers and everything.
Sure. It's sort of a spoken hub. We have a central admin building that has a big beefy server and a strong internet connection. That internet connection is backed up by a Verizon APN. All of our remote sites are actually inside of a private Verizon cloud for security purposes. So each facility ties back into that central building and again amongst themselves through a VPN and the county network. And they can also see each other through the Verizon APN. So there's multiple ways that the different servers can connect with each other. And each one is backing each other's historical data up with the goal that if something were to happen to one server, you still have your data.
Great. So how many levels of redundancy do you think the system has?
Oh, gosh.
In terms of backing up historical data?
You've got, at the water plant, for example, you've got 2 servers on site. So I guess that's one layer of redundancy. Then you've got another layer with being in a different building. You've got that spoke to the admin building. So that's, I guess, a second layer of redundancy.
Yeah.
And then from there, it can go to the other buildings too. So, I mean, really, you'd have to try pretty hard.
That's amazing. So you got a lot of, you've got a whole geographically separated disaster backup of the entire application in a bunch of different locations. That's great.
Oh, so I should mention all the hard drives are rated as well. So
I see.
Another level.
just explain briefly what that means for people who don't know what a RAID drive is. Oh,
sure. Yeah, with rotating media, there is always a chance that something goes wrong and suddenly your hard drive is trashed. So if you put it in I think it's RAID 1, you can basically mirror the data between the 2 drives so that if one fails, you get a warning saying, hey, replace my other drive soon. And it just protects you against kind of localized hardware failure.
Tell us about the testing process. Once you created the new system, I assume you didn't just switch the button on and let it run. What was the testing process to make sure that everything was working right?
Yeah, so what we like to do is once we've installed a new system, don't rip out their old SCADA system, leave that running as much as possible. And we train in the operators to say, use the new system as much as possible. If you encounter a problem or something that doesn't work how you expect it to, go back to the old one, write it down and let us know. And what we actually do nowadays is we'll set up a logbook in VT SCADA so that we can at any computer access that list of problems that they're having. So we can sort of work on it on the fly. And then obviously there's also hardware testing. So whenever we install a new station or make any kind of changes to a station, really, we'll go out and test line by line hardware if I trigger this problem, does it show back up on SCADA? It's time consuming, but it does catch problems. It's worth doing.
Right. Yeah. So you mentioned the VT SCADA logbooks. That's great. Did you make any other use of the electronic built-in encrypted logbook?
Oh, certainly. Yeah. Each station has its own logbook built in, filtered by area, so that when you trend, if you have a problem, you can see on that trend what was going on around that time. So if you replace a pump and now suddenly a couple days later that pump is not working, you might have, a problem with the pump you just installed.
Right. So, James, tell me about how does the customer feel about the new system? What was some of the feedback that you got?
Oh, they love it. They're seeing things that they've never been able to see before. They're identifying I&I issues. They're getting to view things now when they're not at work. If they want a comfort level that the system's doing what it's supposed to be doing when they're when the vast majority of their people are away, which is, in the middle of the night, they can log on and get a certain amount of comfort that everything is happening the way that it should. So they like it.
Well, excellent. Thank you both. Thank you, James Denton and Sam Black of Electric Machine Control. Thanks for your time today. Have a great week.
Thanks, you too.